Hello. This is our flipped classroom for 9/21/15. That's Monday after school sometime. And the first topic is calculator trig. I want to time this, so there, I'm timing it. So there are certain steps on the calculator you should be aware of, and you may be already, but just to make sure. If we want to find the cosine of 28 degrees, we have to make sure that we're in the degree mode. So on the calculator, and this is the calculator that's required for this course. If you don't have one, it's going to be increasingly more difficult as we start graphing sine and cosine curves and so forth. If you do need a graphing calculator. The mode button is right here. And we need our calculator for this lesson, so make sure you have yours. So I'm going to hit the mode button, and when I do that, the line that I'm interested in is the line where it says radian and degrees. So radian degrees, and mine is the third one down. My calculator is set in radians, so I want to switch it to degrees by highlighting it and hitting enter. Now I'm in degree mode. So I can come back to this page if I can find it. So the cosine of 28 is now easy to plug in. Just cosine 28, enter. And I'm going to get this number 0.8829. 0.8829. Alright, so make sure you get that out of your calculator. I'm sure you've done that before. What I want to discuss is secant of 28. Since there's no secant button, here is how I put it in. I say 1 divide cosine of 28, because cosine is on my calculator and cosine is the reciprocal of secant. So I can simply type it in 1 divide cosine 28. If you do that, make sure you get 1.13 and it's your result, 1.13. All right, what about, we'll do a couple more complications. Suppose I have cosecant, and when I have cosecant, I want cosecant of 5 degrees. Trouble writing what's in my head. All right, 5 degrees, 40 minutes, and 12 seconds. Recalling degrees can be divided into smaller parts and those into smaller parts as well. You'll recall from our training earlier that degrees are going to stay the same, but the seconds are parts of 60ths of a degree. So I'm going to break it into a fraction, and each of those is broken into 60ths. So from the original degree, that will be 12 over 3600, or 60 times 60. So when I plug that in the calculator, I get the decimal form, which I need is going to be 5.67 degrees. Now I'm set to go back and find the cosecant of it. So I'm going to plug in 1 divide sine of the number I got over here, 5.67. And when I did that earlier, well, I got something. I'll have to plug it in again. So while you're plugging it in, I'll plug it in. So I got 10.12 as my result. So looking at all that there. And the only other part that I need to discuss as far as calculator trig is the sine of a radian measure. Now we have seen that so many times. It's on our unit circle, so we would need the calculator for this, but we'll see if the calculator knows. So our pi over 6 is here, the long guy over, the short guy up, second coordinate is the sine, so we found it 1/2. If we wanted to tease that out of our calculator, we have to go back to the mode button and we have to choose radians this time. and hit enter. Go back to your calculation screen. Sine of pi. The pi symbol is right there. It's a second function. So it's on second arrow up, and I get pi divide 6. And once I plug that in, sine pi divide 6, I get 0.5, which is what I was hoping for. As my mind and my unit circle had already told me, 0.5 or 1/2. All right, so that's basically all we have to do with calculators, just a little loose end hanging out there. Call that calculator trig in your index or your table of contents, and I forget what page we're on, so we'll talk about that one day when I remember in class. So we can be putting things on the same page so we can find them together. The next and the most important thing tonight is triangle trig, solving triangles. We're going to do that with trig, solving triangles. So solving triangles is when we have a right triangle. We can solve other triangles, but they're going to be right triangles for a while. And when we have a right triangle, we know these functions hold true. Sine of an angle is opposite over hypotenuse. Cosine of an angle is adjacent over hypotenuse. And tangent is opposite over adjacent. All right, these will become pretty important. If they're not really crisp and quick to your memory, go ahead and jot them down again. Let's say we have a triangle and it's 115 on this side. We'll call this leg A, and we know this angle is 78.3 degrees. This one right there. So zoom in for that. Oops. Okay. So with that, we're going to solve the triangle. And what I want to find is A. I want to find this length right here. So since Zach doesn't feel like building this triangle for us in the gym, and we could just measure it, but not all triangles will fit in the gym. In fact, this is 115 feet. Would that fit in the gym? We had trouble fitting the 50-foot triangle in the gym. So no, it wouldn't. So we're just going to pull out some trig and solve it that way. My command is to find side A. And what I do is I have to pick one of these trig functions wisely. So I know this angle, I'm looking for this side, and I know this side. So from the position of this angle, perspective from this angle, this is side opposite and this side adjacent. So which trig function has opposite and adjacent in it? Tangent. So I'm going to say tangent of theta equals opposite over adjacent. And I'm going to put in what I know. The angle I know is tangent of 78.3. And side opposite I don't know. It's called A. And adjacent is 115. Now I just use algebra to solve for the unknown. I multiply both sides by 115. So in the calculator, I'm going to plug in 115 times the tangent of 78.3. And that will be my side A. So plugging that in, tangent. Oh, I got to go back to my mode and change back to degree. I'll stay in there for this lesson, I think. 78, most of them anyway. Tangent 78.3 times 115, and that is 555, and it's in feet as well. All right, I tricked you. You are going to solve triangles like that, but they're not going to look like this. They're going to say something like this, and we'll pull that down in a minute. We're going to say a surveyor stands 115 feet, here's the surveyor, stands 115 feet from the base of the Washington Monument. So, you can do better than that. All right, so the base of the Washington Monument, and the measure of the angle of elevation from the ground to the top of the monument. So I'm going to attempt to draw a straight line. All right, so that angle of elevation, it always goes from the horizontal, which is the ground in this case, to the angle line. So that's called an angle of elevation. And the angle of elevation is 78.3. How tall is the Washington Monument? So I'll put H for height. Do you see how that is the same problem exactly as the one above it? We know the same things, we're looking for the same things. We would use the tangent the same way, and we would get 550 feet. So just be aware that the words that you read will just translate into a right triangle, and you will find the different parts that are given and find the part that is unknown with a trig function. All right, I'll do one more, but I'll shut this down and do it on part 2. Till then.